And I guess we will now crack on with the agenda. We will have the first speaker today is going to be Advanced Infrastructure, and with their local area energy planning application. So I would invite the speakers to share their slides and activate their camera. Great.
Hi, Fabio, just checking you can see my screen.
Yes, we can, Lily. Great, that's great.
Perfect. Hi, everyone. Thank you very much for joining us today. I'm Lily, Head of Product at Advanced Infrastructure. We're one of the Modernizing Energy Data Applications cohort. Joining me today as well, we have Christopher Jackson, CEO, who we'll hear from in a minute, also Advanced Infrastructure, and Rhys Williams, who's Innovation Manager at Scottish and Southern Electricity Networks, who's leading a pilot of our LEAP+ tool. So I'll try and keep the slide web brief today. I'll first run through a couple of slides just to give you an overview of what LEAP+ actually is, and then we'll move on to a bit of a demonstration. So LEAP+, or Local Area Energy Planning Plus, is a collaborative cloud-based design tool. It's aimed at local authorities, energy networks, and consultancies who are working together to transition local energy systems to net zero. For local authorities, it can just simply function as a visualization platform, a way to get all your data in one place. However, we've chosen to take it further and use it as a tool to identify, triage, and analyze project opportunities. For network operators, we are starting the process of making it easier for them to share and communicate their network data from constraints at the lowest voltage levels of the network. For consultants, we've developed a range of clean, processed building level data sets, which make it quicker and easier to model project opportunities, while the LEAP+ tool itself can be used to share project outputs and analysis with clients. Today, we're going to run through a bit of a walkthrough of the tool to look at just a few of the things that you can use LEAP+ for. So upon logging in, the user is able to create multiple instances of different maps. In this case, our planner has two internal maps, one for siting EV chargers and a general energy planning map. They've also chosen to create a public-facing map, which is available as a web page to any resident who wants to better understand what their area is doing to get to net zero. But today, we're going to focus on the local area energy planning space. So when setting up a map, users can choose from a wide array of datasets in the LEAP+ data marketplace. Some are open source and freely available. Others are proprietary, and some have been developed by Advanced Infrastructure as part of the MEDApps program to fill gaps we saw in the local area energy planning data space. Users can, of course, further supplement this data by uploading their own geospatial datasets, street lighting, traffic counters, building stock surveys, anything that a local authority has that would help them with their planning. Once the user's selected their data, the next step is to start exploring their local assets, identifying project opportunities, and triage potential locations for projects. So starting here right at the building level, our user can explore hundreds of different data points relating to their area's building stock. This is essential for building strategic plans that take a realistic assessment of what's actually possible for a given area. In this case, we're triaging houses based on their EPC rating to start with. That's a measure of a house's energy performance. Our user here is interested in promoting heat pump uptake. So they want to identify how many homes have an EPC which is actually suitable for heat pumps that are generally not able to heat homes that are poorly insulated. Our user can scan the area, or as you just saw, they can filter down their dataset until they have a downloadable long list of potentially suitable properties. In this case, however, we're going to overlay a few more datasets to help narrow down a shortlist. This metadata set you can see here links UPRN numbers, EPC data, and hundreds of other building attributes such as height, floor area, roof type, or even the likely presence of low carbon technologies like wind and solar. This data is essential for building up a building level business case for retrofits, but also for assessing the potential for upgrades across an array of buildings or even an entire local area. Moving on to demographic data, our user also wants to target lower income households. To do this, they overlay a GDPR compliant data layer from credit records, which groups the population into dozens of code types and provides an indication of the likely attributes of a given group of individuals. In this case, our user is interested in household income, and they want to focus their work on promoting heat pump uptake among households with an average income of below 30,000. This filter we're applying here can be combined with the others we created earlier around EPC or building type, so that we can narrow down a short list of homes that meet specific criteria, either for a grant, a funding stream, or a local authority's own requirements. We've got some good shortlists here, suitable for building a business case by combining just these 3 data sets. Our user could build that business case offline using the downloaded data sets, or they can continue their analysis within this tool using data visualization and analysis tools available in Leap+. Each user can create up to 5 custom dashboards, just like what you can see here. These have been pre-populated with a few graphs and charts, but the user can also create their own using uploaded datasets, Leap+ datasets, and more. The idea is to make it faster and simpler for users to rapidly identify suitable project opportunities and justify the project business case to funders. Every graph and every dashboard is quick and easy to export as SVGs, PNGs, or Excels, and really easy to situate in a report. I'll now pass over to Christopher to take a bit of a deep dive into one of the Leap+ datasets.
Thanks very much. An important feature of Leap+ is building level demand forecasting. This standalone service within Leap+ offers half-hourly electricity demand forecasting for individual buildings that are part of a local area energy plan. Energy system modeling relies on aggregating or grouping buildings into zones of electricity and gas supply, and then modeling how these populations evolve after time. Our tool allows users to group and aggregate buildings on the fly and to test multiple scenarios of low carbon technology deployments. The user can click on any of 25 million buildings in the UK to view a modeled half-hourly electricity demand profile unique to the building and occupier attributes such as home energy efficiency scores, age, family size, EV ownership, and PV system ownership. On the next slide, we can see this is an important improvement upon the state of the art, which currently uses only a few Elexon profile classes to represent over 25 million buildings. In this example, a row of terraced homes returns very different demand profiles due to the ownership of different low carbon assets according to the family size and different attributes. In the future, the service will use novel anonymization techniques to leverage millions of smart meter records to build representative profiles of electricity demand for all electricity customers. Now, back to Lily.
Looking a bit forward next as to what's after MEDApps. Our next phase of development, post MEDApps, is going to look at going beyond initial site identification and strategic planning and taking things down to project level modeling and simulation. To do this, we're partnering up with network operator SSEN, who's been piloting our software, and network modeling experts, Derryherk, who are providing SSEN with capacity estimates and high resolution, low voltage network models. What you can see here is the current state of the art that's available in Leap+. These are distribution transformer supply areas, which we've color coded according to their spare capacity. On top of this data, we're beginning to allow users to trial siting low carbon technologies within the tool itself and modeling the impact of these on the electricity network by dragging and dropping different low carbon technologies onto the map interface to start building projects. This kind of data is really important because 30% of all energy projects planned by local authorities are cancelled because network connection costs are too high. This is usually due to network constraints that necessitate sometimes very expensive network upgrades to facilitate new connections. This costs local authorities and consultants thousands of pounds on feasibility studies for projects that are cancelled the next day when the network connection costs comes back and rules the chosen project location infeasibly expensive to develop. Meanwhile, network operators are faced with processing thousands of connection applications that never go anywhere. Instead, in this case, our user here has been able to simulate the impact of their proposed assets on the network. And you can see here that they're likely to overwhelm the particular substation's capacity that they're looking at. whereas a substation just to the north looks to have a much higher capacity available. This kind of data is really useful for triaging projects before a connection application is submitted, saving valuable time and money. We're working next to integrate LEAP Plus with powerful power flow modeling tools that model lower voltage network capacities so that we can take the resolution down below supply areas to the individual feeder cables and wires in the last mile of the network. The browser-based format for LEAP Plus is really useful for doing this. It means that we can keep that network data up to date, refreshing it as often as the data becomes available. What you can see here now is the resolution that we're moving towards. This is a model of SSEN's low voltage network produced by a company called Derryhurst, which SSEN are trialing alongside LEAP Plus. Some of this data is surveyed and some of it is modeled. It includes network geometries, i.e. the locations of wires and cables, but it also includes after diversity maximum demand, basically the current and forecast loading on the individual network cables. Having these layers alongside some of the other GIS layers that we demonstrated earlier makes it much, much easier for local authorities and consultancies to take into account network constraints or plan network investments before submitting their connection requests. Users will soon be able to overlay these data layers alongside gas, buildings, and environmental and demographic and fuel poverty datasets, bringing together all the information needed to rapidly assess the renewable potential of a given area and build out project pipelines for hundreds of different assets. I'll now pass over to Rhys Williams from SSEN to talk a bit about how SSEN are using the tool.
Good morning, everybody. Thank you, Lily. Yeah, my name's Rhys Williams. I'm an Innovation Project Manager at SSEN. This slide, there's a lot going on this slide, so I apologize for that. But it's to do with the RAZOP project, and that's an innovation project which we're working on at the moment with AI, that's Lily and Christopher on this call. And a couple of other companies as well, Derryhurst, RAZOP, Dundee City Council and Oxfordshire City Council. Now, the purpose of RAZOP is to give SSE an understanding of how we can better communicate with local councils, how we can share data with local councils, and how that data can be used to improve efficiencies, not only for local councils, but also for ourselves at SSE. Now, Lily touched on this already, so it's useful to know what the current process is and how LEAP Plus is changing and improving that process. So at the moment, a local planner, they'll come up with some kind of siting, let's say for a rapid charger. That may take some time. They'll use whatever internal tools they have, and they'll send it to us for a connection application. Typically, it takes about 30 days for us to return a cost and a time scale for that connection application. As Lily said, 30% of those don't go ahead because of cost and time problems. So what we're trying to do is, instead of the local planners not having any visibility of what our planners have, we are providing our network data in a nice, easy to use red, amber, green format, green being no constraint, red being there is a constraint, amber probably going to be a constraint soon. So easy for anyone to use. You don't need to be an electrical engineer. But we're providing that data very granular, which then allows the planners to make better informed decisions. So when that data or that application does come to us, it's far more likely to come back with a success. So very simple premise. We're also working with RAZOP, who are going to be delivering an LHES and a LEAP. So those of you that don't know what an LHES or a LEAP is, an LHES is a local heat and energy efficiency strategy. That's being mandated by Scottish Government. So all local authorities have to create this long-term plan. on how they're going to decarbonize heat. And then a LEAP, as a local area energy plan, that at the moment is optional for local authorities, and it's going to show how they're going to decarbonize from now to 2045. Now, at present, these are long-term strategy documents which are held in PDFs, which then kind of need refreshing after 3 years approximately. What we're proposing as part of this project is to see if we can digitalize the outputs onto the LEAP Plus tool. So you've always got a view of what your LHEs or your LEAP is over time. And over time, you can see, based on the energy projects you're putting into LEAP Plus, how well you're meeting the targets on that LHE strategy or that LEAP strategy. And from our point of view as well, it gives a network operator a long-term view of where local authorities are planning their investment. So we're doing it for Dundee, but you can imagine if all the local authorities had access to something similar, we could then build up this good long-term visualization of plans going forward on how we're going to meet net zero. And it means we can start planning our investment a little bit more strategically as we have a better idea of where local authorities are putting their LCT investment. I think that's it from me, Lily and Christopher, so back to you guys.
Thanks very much. That wraps up our presentation for now. So if anyone has any questions, please jump in.
Great presentation. Thank you, Lily, Christopher, and Reese. So we have a first question in the chat, which is, does your tool include all the buildings, especially square mile in the city where delivery companies are located?
Yep, so the answer to that is yes. Delivery companies are about 110 trade associations based in London, for those who don't know. So the interesting point to note here is that London has a much greater proportion of commercial properties, and the energy profile of a commercial property is very different to a domestic profile. In the areas that we've been displaying, we're looking at largely domestic areas or mixed use domestic, which is driven more by the demographics of that location. In the centre of London, you've got a very different urban structure. You've got multiple story buildings, and you have more commercial energy profiles. So yes, we have the data for those buildings, the floors, the attribute, who occupies them, and from that one can infer the energy demand profiles. Of course, it's more challenging because you've got a much higher density of electrical networks, and you've got many different ways to connect them. So it's very much more, or it's a much greater challenge the more sparser domestic areas of analysis.
Thank you, Christopher. Thank you. Excellent answer. Since we are talking about your, say, coverage or what's included in the tool, I will have a kind of simple question. I'll quote simple. What is your geographical coverage in terms of data from electricity distribution network operators? We have seen is a key data set for your tool. What is your coverage for that? How much of the data you currently have?
So we often get asked that question, and the situation is that we are only able to visualize the data that the network operators allow us to visualize through data sharing agreements. So with the case of SSEN, in the pilot project, they have a much higher availability of data than the other 5 DNO regions. However, what we can do before the industry transitions to full low voltage network visibility in the coming years is that we model and infer from the open data available what these granular connections look like. So in the case of the other 5 DNO regions, that's exactly what we do in order to support local area energy planning.
Great, great. Yeah, we know it's a big challenge at the moment for the sector. There is another question that came through. It is a bit difficult. So you are in your tool, it seems that you're mixing several types of data, open data, shared data, and partially also proprietary data. Have you encountered any challenges in tracking license compliance so far, or do you expect to have any challenges in doing that when you mix all this?
Take that one, Christopher or Lily.
Go ahead, Reese. Yeah.
Yes, it's a short answer. A few problems. So at the moment, we've got one issue with Scottish Government on using building level data, and we're trying to work around how we do that. But yeah, I would say there are definitely challenges. However, it's just trying to figure out how to overcome them in order to keep the project working. So there's always a way of getting around it and sorting it. But yeah, at the moment we're at this strange point where the regulators kind of pushing electricity operators to share data more and more, but they haven't officially said we have to do that. So we're kind of a little bit ahead of the curve here. And then you've got to consider other data sources such as OSMAP data, how that can be shared or if it can be shared, and who has the overall rights to it and who the end user is. So a lot of different discussions are going on in the background on that. But yes, definitely challenges, but all those challenges at the moment can be overcome.
Right. And probably worth saying one of the main things we've done to do that, to try and reassure data providers who are concerned about that, is to overhaul permissioning for data sets in the way we've designed the tool. So every single data set has its own specific permission, and that's related to who the user is. So if it's OS master map, for example, that can only be seen by those who have a PSG license, then that's only visible to the local authorities, and it's not visible to their delivery partners, the consultants, the OEM providers, for example. So every single data set, it's specific who can actually access it according to whatever the license conditions are.
Clear. That's a good answer, actually. We have another question in the chat. So does your data in the Dundee area, including properties and customers on IDNO networks connected to the SSEN network, to ensure it includes all customers?
Reese, do you want to jump in on that one?
Yes, I can do. So yes, it will do. We have building level data for everyone within the Dundee area. And the way the modeling is done, you need to understand the load profiles from each individual building. So yes, we do have that data as well. In terms of the actual network makeup, so where the service cables are and the LV mains, I believe we have that data as well, because the IDNO needs to make that data available to us for visualization as well. So we do have to have visibility of it. So yes, I am 90% sure we have that data, but I will double check and get back to you on that as well, just in case.
Great. So another questions that we're seeing that local authority officers seems to be an important user of the tool, one of the main users of the tool. Do you provide any guidance on the skills that they will need for being users? Do you expect them to need specific skills to use the tool? And if so, do you provide any guidance for that?
We've tried to design the tool to be as self-service as possible. So it's relatively intuitive to use. There's obviously, we run workshops and there's guidance and wikis on how to use the tool within it, just as you would with any software tool. Where I think we don't supply expertise, and what we're quite excited to be trialing as part of RAZOP, is what a consultancy like RAZOP can bring. in wider guidance of how to formulate, for example, a local area energy plan, and then displaying that as a layer on LEAP+. And that's going to be a really interesting thing to explore working hand in hand, because to a degree, this can all be automated for a local authority, but there likely will always still be need for a consultant to support with the higher level analysis and the more in-depth stuff. Whereas what we're trying to do in the tool is just reduce the time it takes to do a feasibility assessment and to triage your sites, because that's not where the consultant's actually going to be adding their value. And that side of things is pretty intuitive.
Great. Great. Well, and then another pretty general question is, this came up also in the conversation yesterday in our first day. This is a energy mapping tools is a relatively crowded space at the moment. It seems, at least. You may disagree with this statement. Please feel free to welcome your view on that. But how do you think your tool differentiate from others now that are in the market or they are big developed? What are your key differentiators? Or
I think the key differentiator is the ability to build a pipeline of individual projects that put together meet the net zero targets of 2050, and to evidence progression towards that date and that target. And then to be able to communicate that pipeline to the distribution network operators, for them to make strategic investments ahead of need, such that they can support that pipeline. And we think the value in that is not just self-service local energy planning, but also sort of an improvement in the use of investment in capital of a number of percent, which in the energy transition of billions of pounds, just these small improvements on strategic investments make huge returns. So with that in mind and that functionality, we think that's quite a unique approach to a space which may or may not be crowded.
Can I jump in on this as well, Christopher? Just it might be useful to let you guys know why we went with advanced infrastructure on this. So originally, we were going to use a different tool as part of this project, but we had a big scope change when we saw what advanced infrastructure could do. But for us, the main benefit for the tool is around collaborating and being able to share data, not only with just between ourselves and local authorities, but as part of RAZOP, we're also bringing in Scottish Gas or SGN, and I just had an email as well from Scottish Water. So for us, LEAP+ allows us to not only display our data, but also collaborate with other utilities as well on energy projects. So SGN is going to be coming in and trying to use the tool to place hydrogen projects, and then together we can start collaborating and working together between lots of different utilities on a single tool and platform. So for us, that is the main benefit. So yeah, thanks.
That's great. No, it's actually a very good differentiator. Actually, we haven't heard any answer like that so far, so that's great. We have another question in the chat. That is, you mentioned energy performance certificates. How do you handle properties which do not have any lodged energy performance certificate or any EPC data? Yeah.
So we make it up, like the rest of the industry. So without being flippant, in any data set that is available commercially, it is infilled with missing data. That's part of the service. And they use a hierarchy of rules and assumptions to infill that data. So we do exactly that, and we record how we've done that and the certainty we have around that infilled data set. We look at the buildings adjacent to that missing data and other attributes that we can identify around that property, and we make an intelligent, informed guess and record the methods and uncertainties behind that. Now, we think that's a really important approach. It's done in the marketing sector, in the fintech sector, and in the energy sector. And the research we've done to date shows that it's far more important for energy planning to make an assumption and then control that uncertainty rather than not make a plan at all. And the national approach one takes to building these data sets means that eventually that we should have complete national coverage of every building in the UK and be able to identify its progress towards itself being a zero carbon building. And the only cost-effective way to do that is through modeling and infilling data when you don't have actual on-the-ground surveys.
Thank you, Christopher. Thank you. I guess we reached the end of this Q&A session. So thank you, Lily. Thank you, Christopher. Thank you, Reese. It was an excellent presentation. And yeah, I will invite everyone to have a break now. And also, if you have additional questions for advanced infrastructure, please drop them in the chat. They will stay with us on the call until the end of the event, so they will be able to answer any question also in the next hour. Thank you.